Uh, Hello everyone. So this is our project submission for Blazingly Fast Hackathon, and so we gonna go ahead and showcase you the project, showcase how we approach the problem, the challenges we faced, and stuff like that. So hello, my name is Blazingly. I have 4.5 years of experience working in the tech industry. Primarily working as a software engineer. Then I make a career shift in systems engineering, where I first met Rust, and I have around 1.5 years of experience working with Rust. And so I have teamed up with like my one of my best people I've ever met, Yashin. Yashin, can you just go ahead and give your like introduction, sort of, and just kick off the presentation?
Okay, so hello everyone. My name is Yashwin Phalma. I am pursuing my master's degree in data science from Aligarh Muslim University, India. I have roughly around 2.5 years experience in Python, and I have recently boarded the Rust train. As I am a neurostation, I have worked on Exam for this project. We have a Rust Exam project powered by SQLX for Postgres. We can set up PG Bouncer for database load balancers. However, we went extremely simple. We were planning to Dockerize and use Dragonfly failed to achieve funds for AWS hosting and hence went local. So overall, it was really nice working on this project and got to learn quite many new things. So Ali, that's all from my end. Now you may
Yeah,
continue.
yeah, thanks. I think we lost you in the middle, but yeah, I will just like cover that up. So basically, what she was saying that we were having like one of the main challenges that we faced while working with the project was that um like when we were working on this project, there was like a lack of synchronization actually. So we were both traveling and we got stuck at like airports and stuff like that. So so our initial plan was using like a PG bouncer, like a Docker Compose setup. We initially had it set up, and then we can use like PG bouncer for the load balancing. We can use Dragonfly for caching, and we can initially pitch it up to use. Like the state based or the stack based caching as well. But yeah, so and nonetheless we were extremely simple, so that we were pretty much like confident about our submission anyhow, that we will be able to achieve the desired results. So here is our like main.rs file. And firstly I will go guide you through the code base, how we approach the problem, and how like it was supposed to set up, and then on we can proceed with the demonstration video part. So yeah, so we have a very simple like Axiom setup. So basically right now we have one static route, one initial route for handling the redirects, and another is the app routes for creating and deleting the API endpoints. So if I come up here, so we have this particular route, right, for adding the URL. So we are firstly getting the payload. We are now here, we are using something known as hexagonal architecture. So in hexagonal architecture, every entity, right, so it is independent in its own sense. So that we can following the single responsibility principle. For example, we have here like in the DB models, we have URLs, and in the URLs, of course, like we are giving it a long URL. It is firstly using default hasher to hash it up, take the first byte symbols, and generating basically a short code for that. And then it returns, basically it initializes the struct for the same. And then we have addition and deletion queries inbuilt into it, right? So that this particular struct, the URL is self-contained. So the extractor is very simple. It just takes the long URL, creates the short URL, saves into the DB, and that's it. And so same wise, coming up for when the redirectional logic. So here we have the redirectional hand extractor. So extractor basically takes us the state, which basically contains the connection pool, and it basically searches for the existence of any long URL that maps to that particular short URL. And if it finds everything went fine, it redirects to on the corresponding long URL. If not, then it maps the error to app error. Now here is one of the things that we follow the clean architecture here, and that is basically the non-verbose error handling. So we have this app error. So what app error does it? We have the error variance powered by, like, this is the common like great use for this error. And what we have done is for every error in the app error, we are implementing the into response for that. So for we have the into response, and every into response basically maps it into that. So for example, we have invalid shortcode, right? So it basically gets mapped to like a bad request, and automatically becomes a response. So we don't have to hassle for like handling the error. So like that makes our responses, oh sorry, the extractor is pretty simple. So this was a very quick intro to our code base. Let us go over to like the testing part. So I will again, I have two URLs, two browsers open. So firstly, let me go and look for the a good link so that I can add it to. So I have, okay, so I have this summer of code Google. I take this, I paste it here, I make a post request. It takes 125 milliseconds to process it. Also, we are also having the database operations included as well. I copy this. Now I will just use the other one, other browser. This is my other browser. I open it. I paste this short URL. I press enter, and it opens exactly what I wanted. So what if I open a wrong one? So instead of 9, if I make it 1, see, invalid or expired link and the link type. So basically, this is what the clean architecture looks like. Firstly, we have this app error, app error type, and then we use that app error type to basically implement it into response, which makes our extractor super, super, super simple and with no overhead. So yeah, so that's done. Um, so yeah, so that, and also like of course I have to show you the database since is getting created. I make a see, we have this summer of code, and here we get the short code created at a printed at custom alias and expiration date. If you want to set, we can set up the expiration date. So yeah, that's it. And with that said, I think that was the everything. Thank you very much. Have a good night. Bye.